We will now explain how DesiCool works and how it uses nature's own way of cooling without refrigerants or compressors. The DesiCool system is an air conditioning cooling method which operates with no refrigerants or compressors. The system's first and most vital component is the solid desiccant wheel, which continuously rotates at a low speed. The wheel dries the entering outdoor air, lowering the moisture content. The purpose of this drying operation is to increase the cooling power later on in the system. When moisture is taken out of the airstream, the temperature increases as a result of dehumidification. However, the temperature drops again as the airstream enters the next component, the energy recovery wheel. This wheel is also in continuous rotation. The part of the wheel material which is in the supply airstream is cooler than the entering air. Therefore, the air temperature is reduced, normally to a temperature below the initial ambient temperature. This pre-cooled, but still very dry air, now enters the next component, an evaporative cooler. In this step, the cool, dry air is exposed to water, which starts to evaporate. As the water evaporates, energy is needed. It is taken partly from the water, but to a much greater extent from the airstream. The result is a dramatic reduction in temperature and at the same time an increase in moisture. The end result is cool supply air with the same or lower moisture content than the ambient conditions. In the space served by the system, the temperature and moisture content increase as a result of thermal loads from occupants and equipment. This return air enters the exhaust side of the air handling unit. The first component on this side is another evaporative cooler. As the return air passes through, the temperature is reduced and the moisture is increased. The purpose of this is to create low air temperature, which cools the part of the energy recovery wheel in the return airstream. As this wheel can only operate on sensible temperature, there is no increase in moisture on the supply side. This process is indirect evaporative cooling, and it was this process that enabled the cooling of the dry air on the supply side, as previously described. As heat is taken up on the supply side, it has to be released on the exhaust side to achieve the correct energy balance. This waste energy is now used for preheating before the next step in the system. The temperature of this warm air is further increased to 55 to 85 degrees Celsius by a heating coil. The increase needed depends on the demand for cooling. The warm reactivation airstream now enters the exhaust side of the desiccant wheel. When this part of the wheel, charged with moisture which was absorbed earlier during its presence in the supply air, meets the reactivation air, the moisture is heated out from the rotor material. As long as this part of the wheel is in the exhaust air, moisture will evaporate and dry out the rotor material. During this process, the wheel continues to rotate and new recharged dry material turns continuously, ready to start drying more outdoor air. This whole sequence of events is continuously repeated, producing the desired cooling effect.